In today's video, we are going to do the practice questions from the topic coordination compounds, which cover the NEET previous year questions plus some extra questions. Similarly, in another video, I'll upload the NEET PYQs from the topic coordination compounds plus some extra questions. Now let us start the first one. The geometry and magnetic behavior of the complex are. First, we have to calculate the oxidation state of the central metal atom in this complex. Nickel is the central metal atom. Let the oxidation state of nickel be X. Then plus 4 into the charge carried by the ligand, it is 0. Equate to 0. So, nickel is in the 0 oxidation state in this complex. Clear? Next, what you do? Write the electronic configuration of nickel. Atomic number 28. We have argon 3D 8 4s 2. 0 oxidation state means no electrons are lost. Okay. Here we have 2 electrons in the 4s. In the 3D we have 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now look here, this ligand is a strong field ligand. Since it is a strong field ligand, what will happen? These electrons will involve in pairing. They are paired up. And also these two come here, so that s orbital is available. Okay. We also have the 4p0, 4p0, 1, 2, 3, 1, 2, 3, 4, 5. Yeah. Now, how many ligands are there? 4. 1, 2, 3, 4. So we have the sp3 hybrid orbitals. Hybrid orbitals. Here the hybridization is sp3. If the hybridization is sp3, what would be the geometry of the complex? Tetrahedral. Now if you look here, all the electrons are paired up, right? There are no unpaired electrons. So the complex is diamagnetic because no unpaired electrons are there. So what would be the correct answer? Geometry, it is tetrahedral. Magnetic behavior, it is diamagnetic. So correct answer would be tetrahedral and diamagnetic. 2 is the correct answer. Now the second one. Iron carbonyl is. Now look here. Here we have one iron, right? If it is 1, then it is mononuclear. If it is 2, then dinuclear. If 3, then tri. If 4, then tetra. If 5, then penta. Here we have one iron. So it is mononuclear. The third one. The hybridization involved in the complex is which one? What is the complex? This one. First, calculate the oxidation state of the central metal atom. Let that be X. Plus 4 into the charge carried by the ligand, it is minus 1. Equate it to minus 2. So X is equal to plus 2. Which means that nickel is in the plus 2 oxidation state in this complex. Clear? Okay. And now next, write the electronic configuration of the central metal atom. Atomic number is 28. So we have argon 3d8 4s 2. Clear? Okay. Oxidation state is plus 2. That means 2 electrons are lost. Now we remove this these 2 electrons from the 4s orbital. And in the 3d we have 8. 1, 2, 3, 4, 5, 6, 7, 8. Now this ligand is a strong field ligand. Strong field ligand. So these 2 electrons will be paired up. Now we have the empty 4s orbital. these two pair up. We also have the 4p0. 4p0. How many ligands are there? 4. 1, 2, 3, 4. 1d, 1s, 2p. dsp, 2. What is the hybridization? dsp, 2. So correct answer is number 4, dsp2 hybridization. Next one. The name of the complex ion FeCN6 3- is what? So while naming, you have to know the rule that first you have to start with the ligand, right? What is the ligand here? Cyano or cyanido. Clear? And if it is an anion, complex ion, if it is negative, then your iron should be named as ferrate. Ferrate. Okay? Ferrate. So how many Cn are there here? 6. Hexa, cyano or cyanido, it's the same. Cyanido. Next comes the central metal atom, ferrate. You can use the word ferrate if it is a negative ion. See here, it is a negative ion. And then next you have to know the oxidation state of iron, of the central metal atom there. Let that be X plus 6 into the charge carried by Cn equal to -3. So it is in the +3 oxidation state in Roman form. Okay, Roman form. Ion. Hexa, cyanido, ferrate, 3 ions. So which one is the correct answer? The third one. Right? Hexa, cyanido, ferrate, ion. Now we have 2 extra questions. The magnetic behavior of the complex is which one? Okay. What is the complex? FeCN6 3-. Find the oxidation state of the central metal atom. Let that be X plus 6 into the charge carried by the ligand, that is -1 equal to -3. So iron is in the +3 oxidation state in this complex. Clear? Okay, then next, write the electronic configuration. We have argon 3d 6 4s 2. Since the oxidation state is +3, that means 3 electrons are lost. 2 from the 4s, 1 from the 3d. Then in the 3d we are left with how many electrons? With 5. 1, 2, 3, 4, 5. Okay. Also here, this ligand is a strong field ligand. Since it is a strong field ligand, these electrons will involve in the pairing. So they involve in pairing and we are left with 1 unpaired electron. Here we have 1 unpaired electron, which means that it is paramagnetic in nature. Paramagnetic. If there is no unpaired electron, it is diamagnetic. But if there is at least 1 electron or unpaired electron, then it is paramagnetic. If there are many, then ferromagnetic. Clear? The last question. The number of unpaired electrons in this complex is what? What is the complex? This one. You want to find out the number of unpaired electrons. First, find the oxidation state of the central metal atom here, that is titanium. Let that be X plus 6 into the charge of this ligand, it is 0, equate to +3, which means that titanium is in the +3 oxidation state in this complex. Clear? Next, write the electronic configuration. Atomic number of titanium is 22. Argon 3d2, 4s2. If the oxidation state is +3, it means that 3 electrons are lost. 2 from the 4s, 1 from the 3d. If 1 electron is lost from the 3d, then we are left with 1 electron in the 3d. So we are left with 1 electron. So how many unpaired electron we have in this complex? 1. Correct answer is number 3. Okay, so that's all for today's video.